Imagine this for a second. You're in a contested zone, and you hear it. That distinct whistle of incoming indirect fire. Mortars, maybe artillery. You know you have seconds, maybe less than a minute, until impact.
Right.
How does a massive modern military force detect that, locate exactly where it came from, and then launch a counterstrike, sometimes before that first enemy shell has even landed?
That speed, that's the entire goal. And it requires a level of integration that's just incredible. It blends advanced tech with really meticulous layered planning.
And that's what we're here for today.
That's our mission. We're going to take a deep dive into the very complex, very precise world of field artillery target acquisition, or TA, and the doctrine that governs counterfire operations. We're really looking at how they use these weapons locating radars, the WLRs.
So we're basically dissecting the anatomy of speed and precision, using doctrinal sources to trace how a blip on a screen becomes friendly rounds going back downrange.
Exactly. We're focusing on the key unit, the Target Acquisition Platoon, the TAP, which is part of the larger Field Artillery Battalion, or FABN. We need to understand how these teams use systems like the AN TPQ-50, the bigger Minute-53, and the classic NAV-36.
And their job is to calculate where the enemy fired from.
The point of origin, or PO, and also where it's going to land, the point of impact, the POI. That PO data, that is the foundation of the entire counterfire fight.
Okay, so let's start with the unit itself, the TAP. This sounds like it's more than just a few specialists with a radar dish. It seems like a self-contained intelligence and targeting machine.
Oh, absolutely. It is far more than just a dish. The FABN TP is a highly specialized platoon. You've got the Platoon HQ, you've got the Counterfire Operations Section, the COS, plus the actual WLR sections and their survey teams.
And the radars themselves can differ.
They do. The sources note that a standard active duty FABN TAP will probably have 4 AN TPQ-50 radars. Those are the smaller, more mobile ones. But a National Guard TAP might field a mix. They could have the older AN TPQ-36 and the much larger truck-mounted AN TPQ-53.
That distinction seems important. The big truck-mounted one, the NAGA-53, that suggests it's used very differently than the smaller, more nimble NAGA-50s.
It is. But the central nervous system for all of them is that Counterfire Operations Section, the COS.
Okay, so that's the brain of the operation.
That's the core. The COS's main job is to provide responsive and accurate counterfire. Think of them as the targeting cell, the brain trust, that works side by side with the battalion intelligence officer to turn raw data into an actual fire mission.
And who makes up that cell?
It's a very technical group. You have the targeting officer, a counterfire NCO, 2 more targeting NCOs, and 2 target processing specialists, or TPS.
And here's what I find interesting, the division of labor.
Right. It's crucial. The radar operators, the TA personnel, they provide the raw POO and POI estimates. That's key. They're just estimates.
So it's not a finished product?
Not at all.
Yeah.
It's the COS, or the TPS, that takes that raw, sometimes messy data, confirms it, cross-references it with other intelligence, and only then do they generate the official, precise fire mission data. They are the quality control layer.
That makes sense. The sensors and the processors. Let's look at the leadership then. How does the platoon leader's job differ from the platoon sergeants on the ground?
It's a classic dynamic. The platoon leader, the officer, is focused on the strategic and technical side of things. Training, readiness, maintenance, sure, but also supervising the general movement and positioning of the radars.
So they're looking at the map.
Exactly. They're the one advising the commander on technical considerations, recommending the general locations and the search azimuths based on terrain and the enemy threat.
So the platoon leader says, we need to look over there, and the platoon sergeant is the one who actually makes it happen.
Precisely. The platoon sergeant is the senior enlisted advisor. They handle the logistics, the ground reality. They coordinate survey support, which is critical for accuracy. They manage maintenance charts, get resupplies, and ensure the soldiers are trained.
There's a tension there, I imagine.
Always. The leader's technical ideal versus the sergeant's ground truth.
Speaking of that ground truth, let's move from the general guidance to the painstaking process of actually setting up one of these radars. This is where the radar section chief takes over.
That's right. The section chief is the immediate tactical decision maker. Once the platoon leader gives them a general area, they are the one who gets on the ground, personally reconnoiters the land, and selects the final site.
And what are they looking for?
Line of sight, concealment, cover, ground stability, all of it. And once they pick the spot, they coordinate a hasty survey to make sure that radar is perfectly oriented. We're talking within minutes of an angle. It has to be that precise for an accurate POO calculation.
And then below them, you've got the people with their hands on the equipment 234/7, the team chief and the WLR specialist. What's the difference there?
So the team chief is the technical expert, the supervisor on site. They operate the system, they supervise the emplacement, and this is vital, they are the primary troubleshooter.
So there's the first-line mechanic.
Essentially, yeah. These systems are fragile. The team chief is trained to run fault isolation tests, diagnose a problem right down to a specific circuit card or module, and replace it to keep the radar in the fight.
If they can't fix it, the mission just stops.
It stops. Meanwhile, the WLR specialist is the executor. They are the ones physically setting up and tearing down the WLR, initializing the equipment, and sending that POO and POI data back to the COS, all based on a very specific plan called the RDO.
You mentioned maintenance. These sound like complex, hungry machines. They must need support from outside their own platoon.
Oh yeah, that logistics tail is essential but often overlooked. Back in the brigade support battalion, you have key people. There's a radar repairer who can handle more complex issues beyond what the team chief can do.
And power, I imagine.
Crucially, you have the power generation equipment repairer. Radars need incredibly precise, clean electrical power. They can't run on just any generator. If that power falters, the radar is completely blind. It's a non-negotiable part of the system. So all of this structure, all these people, and all this logistics, it all feeds into one single operational philosophy: centralized planning and decentralized execution.
Okay, that's a concept you hear a lot in military. How does it apply specifically to controlling these very expensive, very capable WLRs?
It's all about ensuring that even though individual radar sections have the freedom to move and operate on their own, that's the decentralized execution, they are all working off the same playbook.
The centralized plan.
The centralized plan. They're looking at the same priority targets, using the same rules. And what's really fascinating is that the physical capability of the radar actually dictates who controls it.
What do you mean? Give us an example. Why would one radar be controlled at, say, the division level while another is controlled locally?
Okay, take the big one, the AN TPQ-53. It's a powerful, far-reaching system. It can see targets across adjacent unit areas.
Right.
So if you let every local brigade combat team control their own -53, you'd have chaos. Duplicated coverage, confusing airspace. So planning and control for the NAGA-53 are usually kept at the division level or even higher. It creates one broad, coordinated counterfire umbrella.
And the smaller ones, the -36s and -50s.
They stick with their local unit. They have a much shorter range, relatively speaking, so control stays with the parent FABN. Their main job is to support their brigade combat team's immediate local fight.
Got it. So once that control level is set, all that specific guidance, where to go, when to turn on, when to pack up and move, that has to be written down somewhere. And that's the radar deployment order, the RDO.
The RDO. It's DA Form 5957, and it is the single most important document for employing these things tactically. It specifies everything. And here's the key part. Once that form is filled out with mission data, with the actual locations and search boundaries, it immediately becomes a classified document.
Beyond just the location, what kind of data in that RDO would an enemy kill to get their hands on?
The timing and the intent. For instance, they'd know your queuing posture.
Queuing posture.
It's how long the radar will actually radiate when it's on. A code word like Neptune might mean 30 minutes on, 30 minutes off to try and evade detection. Zeus might mean it stays on for a full hour. The planner is constantly weighing that risk of being seen versus the need for continuous coverage.
So radiating is a life or death trade-off. And that must connect to how often they have to move.
It does. That's the displacement posture. A code word like silver could mean they have to conduct a survivability move after 6 hours. Gold might give them 8. The RDO also forces a full threat assessment with the S2, the intel folks. It details everything from ground threats to UAS to EW, even the MOPP level required for a CBRN threat. It's a complete operational checklist.
Okay, so the RDO defines how the radar operates and when it moves. But the next layer of planning is about what the radar prioritizes. This is where we get into the geometry of the battlefield, starting with something called the Common Sensor Boundary, the CSB.
The CSB is a really critical planning line. It basically partitions target acquisition responsibility between adjacent units, and its placement is not arbitrary at all. It's heavily influenced by the range of your friendly fire support systems and the WLRs you have available.
So the CSB is like a line in the sand that says, anything on this side is my problem, anything on that side is your problem.
That's a perfect way to put it. For example, You can tie the CSB directly to the max planning range of a friendly artillery battery, let's say 155 millimeter cannons. By putting the CSB at that range, the planners guarantee that any target acquired short of that line can be engaged by that friendly battery.
It ensures there's always a shooter ready for a target.
Exactly. It pairs the sensor with the shooter.
So once that boundary is set, you start getting even more precise with zones. Why use these geometric shapes?
The zones are how you tell the radar what to care about most. They align the radar's focus with the commander's intent right now. You can define them with a few grid coordinates or as a circle, but they tell the system which incoming rounds demand the highest level of automated response.
Let's break down the three main priority zones. What's the one that requires the absolute fastest response?
That would be the critical friendly zone, the CFZ, highest priority, no question. It's drawn around things you absolutely cannot lose: a command post, a key supply dump, a maneuver unit in a vulnerable position.
And if a round is predicted to land there,
The system automatically generates a priority 1 call for fire message to the COS. And importantly, the CFZ doesn't even have to be inside the radar's search sector. As long as the radar can track the projectile long enough, it can calculate the impact point.
that automation really highlights the need for speed we started with.
Yeah.
Okay, so if the CFZ protects friendlies, what zone is used to actively hunt the enemy?
That's the call for fire zone, the CFFZ. You place this over areas where you know or you suspect hostile artillery is operating, your high payoff targets. A detection here generates a priority 2 message, but the commander can upgrade it to a priority 1. And unlike the CFZ, this zone must be inside the radar's active search sector.
And the third one, the ATIZ, sounds more like an intelligence tool.
It is the Artillery Target Intelligence Zone. It's basically for long-term observation. You put it over enemy territory to detect weapons and contribute to pattern analysis. It helps planners decide if they need to turn that area into an active CFFZ later on.
Okay, finally, there's the sensor zone, the CZ. This sounds like the opposite of the others.
It is. A sensor zone is an area where the WLR is prohibited from reporting any acquisitions. You almost always place it over friendly weapon systems, like a nearby artillery battery, to prevent your radar from picking up your own outgoing shells and reporting them as enemy fire.
That makes perfect sense for preventing confusion, but it sounds like it creates a massive strategic paradox. You're choosing to be blind in a certain area.
That is the high-stakes trade-off right there.
Yeah.
The paradox is that the CZ ignores all radar tracks coming from that area. So if a hostile weapon manages to fire from inside your friendly sensor zone, and that round is heading for your highest priority critical friendly zone,
The radar will just ignore it.
it is obligated to ignore it, which underlines the absolute need for what the doctrine calls careful planning and characteristic understanding when you use a CZ. You have to have other warning systems in place.
We started this with the sheer terror of an incoming round. And we've drilled down into a system that's built not just on technology, on WLRs, but on these deep layers of human planning and philosophy. Counterfire is this deeply integrated effort.
Yeah.
It's the radar operators, it's the data processing in the COS, and it's that meticulous classified planning in the RDOs and the placement of those zones.
And if you connect it all back, the whole system is engineered for speed. It's designed to generate that automated priority 1 fire mission when a CFZ is threatened, giving the human element just seconds to react. But the sensor zone, that really highlights the constant tension for the planners.
How so?
Well, how do you balance that need for an instant automated response, which demands speed, against the absolute necessity of human verification and judgment, which requires caution? That speed versus security trade-off is the puzzle they have to solve every single day. And it's something for you, our listener, to maybe think about, especially as we hear more and more about automation in all walks of life.
A truly fascinating insight, a dangerous but necessary trade-off. Thank you for guiding us through this deep dive.